Okay, now we're going to implement ArrayStack finally. And the first thing we're going to do here is create our private instance variables, which we already said in the documentation are going to be elements, private int depth. Whoops, I don't want to make that a function. It's a function somewhere else. Int capacity. Okay. Those are our instance variables, and obviously we're going to have to give values to our instance variables somewhere. That is going to be done in the constructor. And there is going to be one constructor for this class, all right, and it's going to come from BoundedStack. Okay, and you can kind of see right there that a concrete class that implements this interface, actually I'll just do it over here, it'll be easier. Any concrete class that implements this interface has to have the following one argument constructor. So actually, let me just go grab that. Copy. Whoops. Copy. And I'm going to paste it here. And this should say throws. It shouldn't say throw. Throws an illegal argument exception. All right, and it's not my stack, it is ArrayStack. All right, so the first thing we have to do, well, usually the first thing we do in a constructor is we set these instance variables to values. But in this case, we have an exception here, and we need to throw that exception. So we know from the Java doc that if max is less than or equal to 0, we are going to throw a new illegal argument exception. Okay, and now we can give values to our variables. Okay, so elements equals. And we would like to say here, this is an array, so we'd like to say something like this. Unfortunately, Java won't let you do that. I'm going to come back to that actually. So the int is, the depth, the depth is the current depth of our stack, so we're going to start with an empty stack. And the capacity is going to be equal to the argument that we passed in. Okay, so let me save that and go over here and say E cannot be resolved to a variable. That's because Java implemented generics in a particular way using something called type erasure, and it basically ignores the type once the compiler it ignores these generic types once the compiler is done with them. So we can't do this. We'd like to do that. We can't do that. So a workaround is to say object max, but that's not going to give us what we want either, because it says the object can't be resolved. Object can't be resolved to a variable. So, actually, I'm sorry, new object, yeah. So, let me take that back. We would have liked to say this, but we can't, okay? So, the error here is cannot create a generic array of E. Okay, that's an error that makes a lot more sense. So what we need to do as a workaround, instead of E there, we need to say object. And then if we save that, we're still getting an error here. And it says type mismatch cannot convert object to E. And let me see if this gives us, yeah, it gives us the choice to add a cast to E. All right. And when we save that, it actually gives us a warning. It's not an error, it's a warning. But one of the things we can do, if you're concerned about that warning, is you can click on this and you can say add suppress warnings here. And it will take that warning away. It's not a big deal. I mean, it is a warning. I do personally like to get rid of as many warnings as I can, but sometimes you just can't do it. I mean, and this is the case where you just cannot do that. Okay, so if you don't want to see these little yellow light bulbs, you're going to have to suppress warnings. These here are probably for unused. Yeah, we're going to eventually use those, so it's no big deal. All right, so the last thing we have to do here is we have to write a Java doc for this. So I'm going to say constructs a new empty stack with empty stack with the specified all right, so I'm trying to work the word specified in there with a bound of max, and I'm going to wrap that max in code. All right, put a period after that. That's going to be the bound of the new stack. And this illegal argument exception is going to occur when, when max is less than or equal to 0. Okay. All right, I think that covers it. Now let's get to these other methods. Most of them are pretty simple. So capacity, it just returns the capacity field. That one's easy. Clear just gets rid of all the elements in the stack. So let's think about this. An empty stack, remember this is something that's called a partially filled array here. That's because only certain elements of the array are relevant to the stack abstraction. Okay, the first elements of the array up to depth -1, up to an index of depth -1. Well, really, if you have a brand new, if your depth is 0, all right, that means none of the elements in the array are relevant to the abstract value of the stack. So to create this clear method, you don't have to go back and put a bunch of nulls in there. You simply have to say that depth equals 0. Capacity is going to stay the same. That never changes, actually. Once you fix that, that never changes. And in fact, that's probably a good reason for capacity to be declared final. I don't think that's ever going to change once you set that value. Let me see if I can declare capacity final and not have anything break on me. Okay. So let's see, the value is not used. Okay, it will be used. All right, so very good. So now we're assigning 0 to depth, and that is going to effectively clear our stack. So depth, we're just going to return depth, the depth field. Is valid. For is valid, we need basically that representation invariant. So let me go grab the representation invariant. Okay, copy that. And put that over here. All right, didn't work out as well as I thought it might. Actually, that's okay. Let's just do that and make that into a comment. All right. Okay, so is valid. Basically, if any of these conditions are violated, you have to return false. So we have to check the elements in the array up to depth -1. So the first thing we do, whoops, somehow I hit caps lock, for int I equals 0 to I is less than depth, I plus. We want to make sure that none of these are null. All right, so if elements I equals null, then return false. Okay, so it's not valid. All right, and what else? Depth can't be smaller than 0 or greater than capacity. So if depth is less than 0, sorry, or depth is greater than capacity, return false. And then we've got stuff about capacity. So if capacity is not equal to the length of the array, then we return false. And finally, if capacity is less than 0, we return false. And actually, now I'm seeing a problem with this representation invariant. How come it says capacity is less than 0? It should say capacity is greater than or equal to 0. So I'm going to go back up and modify this. So capacity equals elements.length, and capacity needs to be greater than or equal to 0. Okay, and what is wrong? Elements dot length. I didn't put a parentheses there. Close paren. Now I'm going to kill that. And instead of returning false, if it passes all that stuff without returning false, then it's just going to return true. Okay, and let's see. For new instance, we are going to return a brand new instance, a brand new stack with, and remember, this is called like this dot new instance. Okay. And it's going to be, you know, assigned to something like stack string s equals or s2 equals s1.new instance. That's the type of thing you are going to see when you're using new instance. So you're creating a brand new stack, and the stack is empty, but the stack is going to have the same capacity as this original stack, as the calling stack. The way you do that is you just use the constructor, and that's you return a constructor. You return a new array stack, okay, with the argument, the capacity, equal to the capacity. All right, and that's it. Basically, you've created a new empty stack with the same capacity as this stack. And we will see why that comes in handy when we're working with secondary methods. And what is this warning all about here? Type safety, the expression of type ArrayStack needs unchecked conversion to conform to stack E. ArrayStack is a raw type. References to generic type ArrayStack E should be parameterized. ArrayStack. Okay, I'm going to have to check this out. Okay, I'm going to leave those warnings there for now, and because I'm not 100% sure whether they're going to have effects. So I'm just going to leave them there, and we'll find out when we do the copy method and when we actually test this stuff if there is an issue. And I wrote this, and I didn't mean to write that. I'm just going to keep it like that for now. Okay. Next, let's do the push and pop methods. Okay, and these methods throw exceptions. Okay, so pop throws illegal state exception. So that's the first thing we check. If the stack is empty, then an illegal state exception is thrown. So if depth equals 0, and throw new illegal state exception. And also, okay, that's it. Push is the one with 2 exceptions. So for this one, we just take the last thing that was popped onto the stack, or pushed onto the stack. And that's going to be at index depth -1. I am going to create a result variable to hold that because I think I need to decrement depth after I take that. So I'm going to say result equals elements at depth -1. And then I'm going to decrement depth. Okay, let me be explicit about that. Depth equals depth -1. And then I'm going to say return result. All right. So that's our pop method. And for our push method, we've got 2 exceptions to worry about. If element equals null, throw new null pointer exception. And if depth equals capacity, throw new illegal state exception. Okay, and if neither of those things are true, then we push an element onto the stack. That means there is room in the array at the index depth. So we do elements depth equals element. Okay, and then finally we need to increment depth because we just pushed something onto the stack. Okay, and like I said, we'll keep an eye on this new instance method. If it turns out that these are just irrelevant warnings, then we'll do a suppress warnings. Otherwise, we'll fix that. And we've still got this iterator to do. But I'm going to do a separate video for that devoted to the iterator so that we can focus on it. Okay, I'll see you there.